Okay, welcome to our lesson for section 3 of unit 1. So I guess lesson 1.3. We do have a guest with us on my lap, hopefully he won't be too disruptive. I'll swat him away if he does. Hopefully he'll be good for us. So I did the same thing for this lesson that I did for the previous lesson. I tried to take what had been provided and distill it so that it's a little bit easier to get our heads around, and hopefully that will work. This video can be used by anybody who is absent from class or anybody who is in class but who feels like maybe there was a section or a slide or a problem that you would like to see done out again. Just get that explanation again. And sometimes I do it a little bit differently when I'm recording the video than I do it in class, and so you might find it beneficial to go over. So the learning target for this lesson is to use linear functions to model and analyze real life situations. It's essentially an application section, which I love because I actually don't like doing math just for the sake of doing math. I like to know what the math does. How is it useful? What does it model? Even if I am not the person who's going to be modeling with it, I'd like to know that somewhere, somehow out there, there is a use for what I'm studying. So this section is going to focus on linear functions. How will you know if you are successful? Well, you'll be able to write equations of linear functions. So given the correct information, you will be able to, sorry, my cat just noticed the pointer moving around the screen. He's very intrigued. So you'll be able to write the function that goes with it, as opposed to me just handing you a function and saying, here, look at this function. I can compare linear equations to solve real life problems, and that has to do with being able to interpret the numbers in the problems. What do the numbers mean? What does the y-intercept mean? What does the x-intercept mean, or the slope? These things actually have a connection to something in real life, and you should be able to compare them so that you can make decisions between, say, several different options. And then the last one is determining what's called the line of best fit. We are going to do that completely on Desmos. We are not going to do it out by hand. You can do it out by hand. There's some interesting activities where you do it out by hand. There's a good Desmos activity that I might assign, but generally, if you need to find a line or any curve of best fit, you will use technology to do it. So the class begins with this opening activity, and what I intend to do is hand everybody an index card and working with a partner, work through this problem here. So a company purchases a demolition robot for $87,000. The spreadsheet shows how the robot depreciates over an 8-year period. So something to keep in mind here is like depreciate. So we kind of need to know what that word means so that we can so that we can understand the problem. Depreciation is the it errored on me that time. One of the things in the curriculum that they assume that you know is that you can write a linear equation given whatever information that you need for writing the equation. So you given like the slope and a point, given the slope and the y-intercept, given any 2 points on the line, and that you know what that process is for writing the linear equation. I know from experience teaching this class that a lot of you are going to blank out. You're just going to say, I don't remember how to do that. So this slide is going to take you through an example. But notice at the bottom, I have a video link down here that I can post in Teams. I can post it in OneNote, okay? And that is an actual whole lesson on writing equations of lines given like whatever information you have. So if this review is not enough and we're like launching into the next thing and you're thinking that was not enough, I need a more detailed explanation, I can link you over to that video, and it's nice. It's like all color coded and I have multiple examples, and hopefully that'll help you out. So I teach this using a particular strategy using slope intercept form. Not everybody does it this way. There's some other strategies, and if you know another strategy or you have a tutor that shows you another strategy, that's totally fine. But here's my strategy. If you think about everybody's favorite form of the equation for a line, it's probably y equals mx plus b, which is known as slope intercept form. And it's called slope intercept form because the m is the slope and the b is the y-intercept. So you have two pieces of information there. You know how steep the line is, and then you also know where the line crosses the y-axis, which is enough for you to be able to graph it. It's very easy to graph from slope intercept form. So if I want to write the equation for a line, I need to know two numbers. I need to know the, I'm pointing at my screen like that's, there we go. I need to go to my touchpad. I need to know the slope and I need to know the y-intercept. Okay. Once I know those numbers, then I can plug them right in here. So I can write y equals something with the x plus something. I just need to know what's going to go in those blanks there. What's going to go in there for the m, what's going to go over here for the b. So that's our mission. We're going to find the slope and we're going to find the y-intercept. So to find the slope, you need to remember your slope formula. And I'll put it up here. Those are subscripts. That's a lousy subscript on that first one there. I'm going to redo that first one. That's a 2. I'm just not happy with that. I got to cram a lot of work onto this slide. Oh, great. I'm making it worse. Okay, that's as good as we're going to get. I'll read it out loud. It is, the slope is equal to y2 minus y1 over x2 minus x1. Now, those numbers are what are called subscripts. Sub means lower, script means writing. So a subscript is just lower writing. And the only reason they are there is so that we can separate the 2 points into point 1 and point 2. Okay, there's no other significance than that, because if you just wrote y minus y over x minus x, okay, that does not work because y minus y is 0 and x minus x is 0, and yeah, that's not going to work. We need to plug some actual numbers in there, and we need to know which numbers go where. Now, it does not matter which point is point 1 or point 2. So I got 2 points here. So we're writing the equation of the line that goes through negative 2, 2 and 4, 5. I can call this point 1 and this point 2, which would make this x1 and this y1, and this would be x2 and this would be y2. You could also say that this was point 1 and this is point 2. Okay, and that would make this x1 and y1 and this x2 and y2. It actually will not matter as long as you don't change your mind halfway through the problem. So once you pick this is point 1 and this is point 2, you are locked into that choice. So with experience, you can sometimes look at the points and say, I'm going to pick them this way because I can see ahead, you know, how this is going to work out. It doesn't really matter. So I guess we'll just go with 1 and 2. Okay, so here we go. Y2 is 5. Y1 is 2. X2 is 4. And then X1 is -2. Now, this right here, everybody's always so excited when you have minus a negative. It's just warms my heart. Okay. No, nobody's excited. We're like, oh, crud. Now, just make sure we're clear on exactly what happened. The first minus sign is from the formula because the formula has a minus sign in it. The second minus sign came in with the value of x. So we actually had a negative number. So that's why we end up with the two minus signs. One is from the formula and the other is from your x value. But it's also very uncomfortable. So I would normally skip this step, okay? But I won't because I'm in teacher mode. But when you subtract a negative, that is the same as adding. You could go back to the middle school thing that high school teachers hate, which is the keep, change, change. Okay, keep the first number, change the operator, change the sign on the second. So 4 plus 2. I was always taught that there's no such thing as subtraction. Subtraction just means add the opposite. So we would add and then think, what's the opposite of -2? Oh, that would be +2. Okay. And what is it? What does this end up being? We end up with 3/6, which simplifies to 1/2. Now I'm going to come back over here to my equation, because remember the goal says write the equation. Well, now I know my m value, so I'm going to go ahead and put in my m value because my n value is 1/2. So I'm getting there. I'm getting there towards my equation. Okay, 1/2 x, y equals 1/2 x plus. Now I need to know the y-intercept. Now, sometimes I have students that will just pick one of the y coordinates, but that's not the same thing. Okay, the y-intercept is where the line crosses the y-axis, and it's not crossing at 2 and it's not crossing at 5. So rather than pick the 2 or the 5, you can actually know you're not going to pick the 2 or the 5 because it can't be those. If you look at, they can plot those points and see where they are, not on the y-axis. So my strategy for doing this, and there's a lot of different strategies for doing this, but I use the borrow a point strategy. Okay, borrow a point. Now think about the word borrow. Borrow means you take something, you use it for a while, and then you give it back because you don't actually want to keep it. So you give it back. So what we're going to do is fill this in, and I'm going to borrow a point. So I need an x and a y, not just a y. I need an x and a y for my equation, and I conveniently have two x's and y's to choose from. I can pick x is -2 and y is 2, or I can pick x is 4 and y is 5. Just once you decide which point you're going to use, like, stick with it. I'm going to use this point, and I'm going to stop talking for a moment and let you think about why I picked that point. Okay, so hopefully you had a chance to think about it. And the reason I picked that point is because it doesn't have the negative. Okay, that's the only reason. Either point will work. They will both give you the same answer. Maybe you don't believe me, you can try it out on your own. Okay, but either one of them will give you the same answer. So now let's go ahead and plug some stuff in. I need a y value. I'm going to borrow the 5. I need an m value, which conveniently I have. I need an x value. Now, if I pick the 5, I have to pick the 4 that goes with it. If I had picked the other point, okay, I would have 2 and then -2, and that also will work, okay? Once you plug the numbers in, it'll give you the same answer out. All right, you can use a calculator for this. You can just do 1/2 times 4, or 1/2 of 4, which is 2, and then subtract 2 from both sides. So 3 is equal to b, and then that's the other number that I wanted. So coming back over here to my equation over here, There it is. All right. And I have written my equation because I went and found M and then I found B and then I just plugged the M and the B in and ta-da. Okay. There's other ways to do that. There's actually other forms of an equation of a line that you can use. Now, if that was a little bit fast for you, okay, and you're like, or you just want to see some more examples. And again, I don't always explain things exactly the same way from one video to the next. So it might be worth checking out the other video. I know it's the same teacher, but I am not actually a clone. And every time I explain something, it does come out a little bit differently. So you can check that link out. If you can't click it from here, which I don't think you can because it's a video, I might be able to link it in the YouTube. Might be able to link it in the YouTube video. I've never done that, but I could try. All right, so that is that with writing the equation of a line. And because the thing froze, I'm stuck in frozen mode. Okay, I don't think you guys can tell that there's a break, but I obviously had a break there. So here we go with some practice. So in your notebook, work out the equations for the lines below and then check your work with Desmos. So once you have an equation, go and graph it on Desmos. And then, of course, if you're making this up from home, you don't need to share your work with the class. But so the first one is write the equation of the line going through -1, 1, and 1, -5. Sorry that the point got a little jacked up there. Okay, it's -1, 1, and 1, -5. Okay, and then what you should do is when you have your equation, go to Desmos, put in your equation, and actually see, does it go through the point -1, 1? Does it go through the point 1, -5? If it does, then you have the confidence of knowing that your work is correct. If it doesn't, then you know you've made a mistake. You need to go back and try to find it. You can message me. Now, the second one is write the equation of the line with a slope of 1/2 and going through -2, 2. That's actually easier than the one that I did because in my problem, I had to find the 1/2. This time it's already given for you. So if you're thinking y equals mx plus b, you already know the m, and all you need to do is find the b, which is not 2, because 2 is not on the y-axis. But you can do the same thing, borrow the x and the y, okay? And then you can find b, and then you can fill it in, and then go and graph it on Desmos and see if it matches, all right? Use that graphing utility for everything it's worth. You're allowed to use it, so use it. All right, the next thing is we want to look at how lines connect to and apply to real life situations. They are super common. There's tons of stuff in the real world that is linear. And even when something isn't linear, we will often find a way to create a mathematical model that is, because the lines are nice. So what we have here is it says the graph shows the remaining balance Y on a car loan after making X monthly payments. So we have balance on the Y-axis, okay, in thousands of dollars. And then on the x-axis, we have the number of payments. So as time goes on, you make more payments and the balance or the amount left on your loan goes down. And we are asked, write an equation of the line and interpret the slope and the y-intercept and what is the remaining balance after 36 payments. Okay, and then the second question is interpret the meaning of the x-intercept. So this is why you need that foundational skill, probably with a generic problem, before you start jumping into the application problems. And that, of course, is something I added. I added that problem. So remember, we want to write the equation for the line. And so we need y equals mx plus b. And so we need the m and we need the b. We need to be able to fill in those blanks. So I have 2 points there. I have the point 0, 18 and the point 10, 15. Here's my formula for slope. y2 minus y1 over x2 minus x1. That's a minus sign. And it doesn't matter which way you plug those numbers in. Just once you commit, you have to stay there. So I'm going to go with 0.1 and 0.2, but if you feel like being a rebel while you're watching this video, go pick them the other way and just see that they come out. We get the same slope. So y2 is 18, y1 is 15, over y2 is, or x2 is 0, minus x1, which is 10. 18 minus 15 is 3 over negative 10. So let's talk a little bit about that negative there. Oh, I need some space. Okay, I'm going to do a little scratch work right here. I'm going to erase it. Okay. If you had negative 1 divided by 2, 1 divided by negative 2, and negative 1 over 2, okay? Yeah, I could ask you, like, hey, hop on a calculator and do all that out. But we can reason this out. If you have a negative divided by a positive, I'll let you think about it. The answer is, and you should be saying, negative, okay? So this would be negative. And then we're left with just what's 1 divided by 2. Well, that is 0.5. Okay. Now, moving on to the next one. What is a positive divided by a negative? Also a negative. And then 1 divided by 2 is 0.5. And then here we have negative of 1 divided by 2. And you can do this on a calculator if you don't believe me, if I don't seem trustworthy to you. So now the point of that little illustration is you can move that negative wherever you want it. You can move it from top to bottom, out in front. Typically, you will see the negative either in the numerator or out front. In the denominator is not as common a place to put it, but it's not wrong to put it there. I just wanted to illustrate to you that you can move that wherever you want. So I told you I was going to erase that because I don't actually want that. That's part of the video bonus. So when I go to plug my slope in, I'm going to go ahead and put the negative in the numerator, but I didn't want to do that without an explanation because a lot of you would think that I just pulled like negative voodoo, like just move stuff around. And you always want to question that if you don't know why something can move, because those things do matter. Now, the other number that I need is the y-intercept. So we can go through the process of finding the y-intercept, but if you're observant in the problem, you realize that we don't need to. The y-intercept is where the line crosses the x-axis, and I can clearly see there that the y-intercept is 18. Now, if you want to write 18, that's okay. What you need to remember, though, and let me get rid of my mess there, is that it's in thousands of dollars. So actually, the y-intercept is 18,000. I think for the most part, you can be pretty flexible about that because the math will often work out either way, but just be mindful that like that actually was 18,000. All right, so there's the equation of our line. Now you could also do the little substitution, borrow a point strategy. So if you'd like to see that, I would pick the 0, 18 because it looks easier. So 18 equals the slope was negative 3 over 10 times 0 plus b. Told you 0 is my favorite number. And then you can get 18 is equal to b that way. All right. So the question there is, what is the remaining balance after 36 payments? So I do need some space here. I'm going to erase my scratch work for finding b. If you need it, pause the video. I guess you can rewind it. It's a video, right? Can rewind time. So we are asked to use it. So it says, what is the remaining balance after 36 payments? So we need to take our equation and we are going to plug in 36 payments and then make sure we add that 18,000. I don't know if I can do this in my head or not. 90 plus 18 is 108 divided by 10. I got to be careful. There is an issue. Okay. I got to be careful here. Because, well, yeah. Okay. We got to be careful. I got to think this through because I mentioned this was the 18,000 and you want to remember that, and you do. That hasn't changed at all. What I'm second guessing as I'm doing this though is that the slope that we found was not using the thousands on it. Okay, so technically this would be like 3,000 over 10, which actually might even be nicer to deal with because it would make it divide nicely by the 10. It's kind of like an issue with when you pick something, you have to stick with it. So back over here where I made the decision to not use the thousands, I have to be consistent with that decision over here. Otherwise, the numbers on either side don't match up. So I know I just did that. And the thing that tipped me off on that was that this was going to come out to a decimal, and I thought, wait a minute, but it's okay. So that was 108 divided by 10, which would give us negative 10.8 plus 18, which is 7.2. And then you want to remember that that is in thousands. Okay. So $7.2 thousand, which is better known as $7,200. Okay. So you'd move the decimal point over 3 times. So sorry about that. And I guess when I do make mistakes like that, I want to be modeling for you how to be cautious in your problem solving, how to be alert and begin to recognize when something doesn't seem to line up, and that's okay. And you just go back and you do exactly what I did. Go back and rethink, what in this isn't matching up and what do I need to do to make that adjustment. And I don't want you to think that just because I do a lot of math and I've done it for a long time that I don't ever get anything wrong. That's not any of us. So, and so when I made that decision back here, I needed to make sure I was consistent. I could have used the thousands here, and then I could use the thousands over there, and we would still wind up with the same number. Okay. It might have even been nicer because we would have avoided the fact that that was in thousands there. So, feel free to try it a different way. Yeah, feel free to try it. I might do it a different way when I do it in class. So, all right. So below is a table of values for a prospective prom venue. This comes out of a kind of a big word problem bank. It's like a big, long, drawn out problem where there's 3 different prom venues and they approach it from all these different angles. But again, remember, I kind of was thinking, okay, that problem's a little bit too much and it's hard to get your head around it. So let's say this is a prospective prom venue. This is the cost for Lakeside Inn. So if a number of if 100 students go, the total cost will be $1,500, 125, and so forth. And so the first thing we need or asked to do here is to write an equation for that data. So again, that's that foundational skills. I am going to pick 2 points. Now you can pick any 2 points. You can pick these 2 points. You can pick these 2 points. You just got to pick 2 points. You could pick this point and this point. They don't have to be next to each other, okay? It doesn't matter. Just you need 2 points. So I tend to bend towards the first 2 points because the numbers are smaller and for no other reason than the numbers are smaller. You just have to pick 2 points off of this table. If you think that another set of points works better, you can knock yourself out. Okay, you can try that. So we're going to use, for the video, we're going to use 100, 1500 and 125 1,800. And again, I'm going to find the slope. So remember to write the equation. We're going to do y equals mx plus b. And we need to figure out what m is, and we need to figure out what b is so we can go fill in those blanks. So my slope formula is y2 minus y1 over x2 minus x1. Okay, and I'm going to go ahead and pick 0.1 and 0.2 because I think that's going to come out nicer. And so this will give me y2 is 1,800 minus y1, which is 1,500, over x2, which is 125, over x1, and that is 300 over 25, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12. So here's my 12. I'm going to go ahead over here to my equation, and we'll put in 12. So the slope is 12. 12 what? $12 per student. All right. Yeah, I'm like double checking, like, does that even make sense? Okay, so now we need to find out what the y-intercept is. So we're going to play borrow a point, and I'm going to borrow this point for no other reason than it has the smallest numbers. If I wanted to, I could go back to my table and I could pick up any point off the table. Okay, it's borrow a point. But I like to make things easy on myself. So my y value that I'm going to borrow is 1,500. My slope value is 12. I just found that. My x value that I'm borrowing is 100. And now the only thing I don't know is my y-intercept. So we'll do 1,500. 12 times 100 is 1,200. And then we'll go ahead and subtract that 1,200 from both sides. And so 300 is equal to my v value. And so I'll come over here and put 300 into my formula. And there you go. So our equation is y equals 12x plus 300. And I got to write that down because we're going to want it on the next slide. All right, and let's just make sure before we leave this slide, because I can't click back in a video, that y is the total cost. So the total cost is equal to 12 times the number of students that go plus this additional 300. All right. So pretty much what that means is that Lakeside Inn is going to charge you $300 to reserve the site. They're going to charge you a $300 flat fee that is for whatever. If one kid comes to your prom, then you're going to pay, the $300 anyway. And then they're going to charge an additional $12 for every student that is planning to come. And that can be for the food. I'm not into planning proms. So, but that could be like wear and tear on the facilities, toilet paper on the restrooms, whatever. Okay. Oh, I didn't even know we had that going on. I was so excited that I just went and solved the problem. Okay, so now that we have that equation, this gets into that second skill, which is be able to compare. So we've covered how to write the equations, we've covered how to apply them to a word problem, and now we get into the part about comparing. Can you compare two linear equations together and make decisions? So rarely will a prom committee advisor, whoever's in charge of planning proms, not me, we'll look at just one venue. You're going to look at different venues. AC has their prom in different locations, like all the time. Okay, so we've had it at the Jaguar Stadium. We've had it. I don't even know where they had it last year, but it's not always in the same place because you're going to look at different venues and see what each venue can offer you for what price, and you're going to try to get the best deal. But in order to do that, you have to understand what these numbers are and how to put them together in a meaningful way. So we have two prom venues charge a rental fee plus a fee per student. Okay. The table shows the cost in dollars for different numbers for Lakeside Inn, and we already tackled that part. Okay. So Lakeside Inn, we already determined, was equal to, oh crud, a different cat just laid on top of it. Okay. 12x plus 300. Okay. And the total cost in Y dollars for X students for some place called Sunview is represented by this equation, Y equals 10x plus 600. And so the question here is, which venue charges the greater rental fee and how many students must attend for the cost to be the same? So notice what we got here. We've got a cost per student and then a rental fee, and we're adding them together. So one of these is the cost per student and the other is the flat rental fee. The cost per student is the one multiplied by the number of students. So you take the cost per student, multiply by the number of students, so that gives you the cost for the students. The other number is your rental fee. So which venue charges the greater rental fee? That would be Sunview Resort, charges the greater rental fee. Now, the second question is a little bit more difficult. How many students must attend for the total cost to be equal? So to answer that, we need to set up an equation. We want to know, when does Sunview Resort equal the Lakeside Inn? When are they going to be the same? So Sunview Resort was 10x plus 600. Lakeview Inn or Lakeside Inn. So we have Sunview and Lakeside. Getting my prom venues all mixed up here. Okay, and we want to find out where those are equal. So this is a linear equation, and you can solve this however floats your boat. I like to keep my x's positive, so I'm going to start by subtracting 10x from both sides. And we'll get 600 is equal to 12x's minus 10x's is 2x's. And now I have run out of space. So this is like bad form, but I don't want to delete that. So, or erase it. I still want it to be up there. I am going to hop on over here. Try not to do that on stuff that you want me to grade though. Okay. And then I'm going to subtract the 300 from both sides. And so 600 minus 300 is 300 equals 2 times x. Divide both sides by 2. And we get 150 is equal to x. And so how many students? Oh, that looks like an 8. My 5 got a little messed up there. 150 students. If 150 students attend, then the two would be the same. And you can also graph both of these and look at where the graphs intersect. That gets into systems of equations, which we have not talked about. I know you talk about them in Algebra 1, so hopefully you can draw on that scale a little bit. There's other ways that you could figure this out. You could even answer this question by guess and check. So if you are in a pinch on a test or something, rather than quit and give up, you don't quit and give up, but you could just say, okay, I'm just going to plug in like 100 and see if they're the same. I'm going to plug in 200 and see if they're the same. And then, you can balance it out and you might be able to come up with it. Certainly better than skipping it. And that brings us to finding lines of fit and lines of best fit. And so data do not always show an exact linear relationship. In math world, like for the Explore, you get these dots and the dots are in a like perfect line. Like maybe they just go up and it's like a perfect line. But if you've ever taken a science class, you know that real life is messier, and what happens in a textbook doesn't necessarily match what is going to happen in real life, even if the relationship is genuinely linear. So when we're talking about a line of fit or a line of best fit, you might have data that is sort of like a line, but it's just not perfect. Okay. And so what we don't want to do with this is start going like this. Okay. That's not how that works. Okay. A line of fit is a line that approximates where your data values are laying. So I'm going to put 3 lines on here. I don't know what to do with my last one. Okay, and if I were to ask you which one of those three lines best models the data, I'll let you think about how you'd answer that. Hopefully you would say the orange one. Okay, the green line is not near the data. Okay, so my data is up here and the points on this line are down there, so that's not right. Now both the orange line and the blue line could be considered lines of fit, but often we're interested in the line of best fit. Okay, like what's the best thing going on here? So the line of best fit here would be the orange one. Even though the blue one does go through some of the points, it's further away from more points than the orange line is. So the idea of a line of fit is a line that approximates your data. The line of best fit is the line that comes as close to as many data points as possible. And there's some pretty high-tech, mathematical ways to figure that out. The line of best fit does not have to go through any of the points. So in this case, it looks like my line does go through that point, but it doesn't go through any of the other points. It doesn't have to go through any of them. Okay, and I want to be really clear with that so that you know what you're trying to find when you're finding the line of best fit. Now, you can do this by hand, and it's kind of what I just did. You draw out a graph on a piece of graph paper, you plot the points, and then you take your ruler and you draw your line through those points in whatever looks best to you. But of course, that is going to be subject to a lot of error. So we are going to be doing this completely with Desmos. Oh, and it's going to let me do it. All right. So I didn't know if it was going to let me record this. I hope that this works. I don't know that it will. So what we have here is we have a table showing femur lengths in centimeters and height in centimeters. So your femur is your thigh bone. It's the bone, the big bone in the top of your leg. And what we want to get out of this is there a relationship? And I guess it says, do the data show a linear relationship? Is there a linear relationship between the length of someone's thigh bone and their overall height? If so, write an equation for a line of best fit and use it to estimate the height of a person whose femur is 35 centimeters long. So we should be able to do this fairly accurately. And we're going to do the line of best fit, not just any old line of fit. So we're going to add our table. And here we go. I'm just going to throw that data in. So 40, I'm going to go down the X column first because it's a little bit faster. And I'm just typing the numbers in. Okay. And then well, I guess we'll do it this way. Okay. And I guess we'll just go up. 182, 185. And nobody can yell out in the middle of the video if I type something in wrong. Okay. So there we have our table in there. And you can probably deduce that there is a relationship here, but it's not going to be perfectly linear. Now, I can't see any of my points because my window over there is not great. So I'm going to use my zoom fit. And absolutely nothing happened. There we go. Okay. Now, what you can see over here is that it is linear. Those points are clearly in a line, but it's not a perfect line. This is just not a perfect line. It's a little bumpy. It looks like we've got like 2 points that are kind of right on top of each other. Okay. Yeah, that doesn't quite work. Now, what we're going to have it Desmos do for us is we're going to have it Desmos come up with the equation of best fit. Now, to do that, you need to know some of how this works. If we look at the table has x1 and y1. So we need to type in x1 and y1 when we're typing this to tell Desmos, hey, reference the table. Okay, so we're going to use y equals mx plus b, but it's going to look a little wonky. We're going to do y, but remember we need y1. We want to make sure that Desmos goes back to the table. So y1, then instead of an equal sign, we need to use a tilde. And that has to do with the syntax and the coding. It has to do with how Desmos talks. If you don't like it, talk to a Desmos programmer. And then we'll do m x1. And all you have to do to get the x1 is just type x and then the number 1, and it will automatically do the subscript. And then we need plus b. Isn't that beautiful? Look at that. So beautiful. And so you can tell the line, it does look like it actually goes through a couple of the points there, but it doesn't go through all of them. And if I scroll down, Desmos is going to give me the equation because real life has crappy numbers. Okay. And so we end up with, okay, so in case my thing wasn't showing up, so it goes through a couple of points. But here are the values. Now, don't worry about the stats pieces on there, okay? Or the residuals. We don't care. What we care is about the parameters. What does m equal and what does b equal? And notice that it's actually pretty terrible numbers that we have there, okay? And that's because real life gives you pretty terrible numbers. But let's go ahead and grab those numbers and put them into an equation. So y equals m is 2.6. I'm going to round it to the 2.6 x, and then see how the y-intercept there is 64.996. I'm going to go ahead and round that up to 65. Where you should round to is always kind of up for debate. All right, so yeah, it just is. So always ask. And then the second question is, use it to estimate the height for a person that is 35 centimeters tall. So remember, the height of a person whose femur is 37 centimeters. So you're asked for the femur, so we're going to plug in the 35 in there, and then we would use our calculator. I'm just going to grab the calculator. And I got 156. So 156 centimeters. Okay, I'm suddenly panicking that did not record. Yeah. Did it kick me out of the recording? All right. I don't even know where we're at, and I don't know if this is still recording. So the practice, this is the last thing, is actually you're going to submit this for a grade by taking the screenshot of your graph and writing your name on it and posting it in Teams question discussions channel. You can do this from home, okay? And I expect you to do it to demonstrate that you have done this. So plot that, find the line of best fit, and then estimate the height for somebody whose humerus, that's a arm bone, who is 40 centimeters long. I have this awful feeling that the video kicked me out. If it didn't, I'm glad I finished it, but if it did, nobody cares anyway. All right, and that is the